Hey, welcome back to AI Governance Pro. If you're studying for AAIA, AAIR, or AAISM, or honestly any of the three, this series is for you. Every episode, we're going to take one exam concept, break it down in about 5 minutes, and then test it from all three angles: audit, risk, and management. Because here's the thing, ISACA tests the same underlying concepts on all three exams. They just ask about them differently. Today's concept, the AI lifecycle. Let's get into it. The AI lifecycle isn't some side topic. It shows up as a major domain on all three exams, just seen through a different lens each time. On AAIA, it's Domain 2, AI Operations, and that's the audit lens. It's the single heaviest domain on the exam at 46%. On AAIR, it's Domain 2, AI Lifecycle Risk Management, the risk lens. It's 21% of that exam. Governance and program management actually carry more weight there. On AAISM, it lives inside Domain 3, AI Technologies and Controls, the Security and Management lens, also the heaviest domain at 38%. So no matter which exam you're sitting, if you don't know this life cycle cold, you're leaving points on the table. Let's fix that. Here's the fastest way to learn this. Most of you already know the traditional IT system development lifecycle, the SDLC, from CISA track work. So instead of teaching you a brand new framework, I'm going to map the AI lifecycle right on top of it. 7 stages on each side. Let's walk through them. Stage 1, plan and design, next to feasibility and planning. Same idea. You're scoping the problem, defining objective, requirements, and success criteria, deciding if this is even worth building. Develop business case and perform risk assessment early to set strong foundation for the following stages. No real difference here. Stage 2, data collection and processing, next to requirements definition. This is our first real divergence. In the SDLC, data is just something you use to test the system once it's built. In the AI lifecycle, data is the core system. Data quality, bias, and where that data even came from, that becomes its own audited stage. In this stage, the relevant data is gathered, cleaned, labeled, and organized for quality. To ensure data quality, dataset must be separated into 3 groups: training, validation, and testing for cross-validation. Stage 3, model building and training, next to design and development. Second divergence, and it's a big one. In SDLC development, a developer writes deterministic rule-based code against a fixed spec. Same input, same output every single time. Model building and training works completely differently. You feed processed data through your developed algorithm, adjust the models to reach the desired performance, and the system statistically learns patterns from the data on its own. The output isn't handwritten instructions. It's a set of tuned weights. And correct no longer means passing a spec check. It means good statistical performance. That's a fundamentally different kind of correctness, and it's exactly the kind of distinction ISACA loves to test. Stage 4, test and validate, next to testing. Similar concept, you're checking the system work such as accuracy, reliability, and fairness before it ships. Stage 5, deployment, next to implementation. Same idea, putting it into production, go live in real-world environment. Stage 6, ongoing operation, next to maintenance. Third divergence. SDLC maintenance means patching bugs when something breaks. AI monitoring is different. You're monitoring AI performance, watching for drift, meaning the model's performance degrading over time as the real world changes. And when that happens, the fix isn't a patch. It's a loop back to the data stage for retraining. This life cycle doesn't really end at deployment. It circles back on itself, connected through interactive feedback for improvement. Stage 7, decommission, next to disposal. Same concept, retiring the system safely, ensure safe shutdown and responsible removal of model and data. So out of 7 stages, 4 are basically the same idea wearing a different name. 3 are where AI genuinely changes the game, data as its own phase, training instead of coding, and monitoring that loops instead of ending. If you remember nothing else from this video, remember those three. Quick recap before we test you. It's the same 7-stage shape as the SDLC you already know. Data collection and processing is its own phase. Focus on gathering, cleaning, labeling, and organizing data for quality. Model building and training statistically learns patterns instead of coding to a spec. Focus on algorithms, tuning models, and learning from data. Monitoring loops back into retraining. It doesn't end at deployment. And know which domain tests this on your exam. AAIA Domain 2, AAIR Domain 2, AAISM Domain 3. All right, let's see if it's stuck. 3 questions, one from each exam's point of view. Question 1, from the AAIA, the audit, perspective. Which control should an AI auditor verify before a model is promoted to production? A. The model achieved the highest accuracy score. B. The training data has been independently validated and model approval has been documented. C. The development team completed coding on schedule. D. GPU utilization remained below 80%. The answer is B. Here's why. An auditor isn't grading the model's technical performance. That's not their job. They're looking for governance, evidence, and control effectiveness. Was the data validated independently? Is there a documented approval trail? That's what makes something auditable. Notice how A and C are tempting because they sound like good outcomes. But neither one is a control. Question 2, from the AAIR, the risk perspective. An organization discovers that customer demographics have shifted significantly since a model was trained. What is the primary AI risk? A. GPU failure. B. Model drift resulting from changing data characteristics. C. Database corruption. D. Source code defects. The answer is B. Model drift. This is stage 6 from our lifecycle map, right back on screen. AAIR is all about identifying, assessing, and managing AI risk throughout the lifecycle. And drift is the textbook example of a risk that's unique to AI, not something you'd ever see called out this way in a traditional SDLC risk register. Question 3, from the AAISM, the management perspective. Which action best demonstrates effective management oversight during AI deployment? A. Personally reviewing every prediction. B. Establishing governance, defining performance thresholds, and assigning monitoring responsibilities. C. Writing the deployment scripts. D. Selecting the machine learning algorithm. The answer is B. Notice the pattern across all 3 questions. A, C, and D all describe someone doing the technical work. AAISM is testing whether you understand that oversight means setting up governance and accountability structures, not personally doing the implementation. If you catch yourself picking the hands-on answer on an AAISM question, stop and ask whether that's really a management action. And that's the AI life cycle from all 3 angles. Quick recap of the mindset for each exam. Think like an auditor for AAIA. Think like a risk manager for AAIR. Think like an AI manager for AAISM. Now, 3 questions is a good gut check, but it's not enough to walk into that exam room confident. That's exactly why I built a 150-question practice bank that covers this domain, and every other domain, in the same format you just saw. Exam realistic questions, 4 answer choices, and a full explanation for every single one, so you're not just memorizing answers, you're learning why they're right. It's weighted the same way the real exam is weighted, so you're not wasting time overstudying the light domains and understudying the heavy ones. And it comes as an interactive digital workbook, so you can drill it on your laptop, track your score, and retake it as many times as you need before test day. The link is in the description below. Go grab it and let's get you certified. If this video helped, hit subscribe. We're doing one concept like this every episode until you're ready for exam day. See you in the next one. Good luck.